Good morning everyone. Today is the day 4 of the Python training. My name is Sejin Park and I will lead you from day 2 to day 5. So yesterday on day 3 we learned about essential Python language basics, IPython and Jupyter notebooks. Today we are going to learn first about data structures and sequences, and secondly functions, and last of all files and the operating system. Let's get on to part 1, data structures and sequences. Python data structures are simple but powerful. Mastering their use is a critical part of becoming a proficient Python programmer. A tuple is a fixed-length, immutable sequence of Python objects. The easiest way to create one is with a comma-separated sequence of values. When you are defining tuples in more complicated expressions, it's often necessary to enclose the values in parentheses, as in this example of creating a tuple of tuples. You can convert any sequence or iterator to a tuple by invoking tuple. Elements can be accessed with square brackets as with most other sequence types. As in C, C++, Java, and many other languages, sequences are indexed in Python. Since the size and contents of a tuple cannot be modified, it is very light on instant methods. A particular useful one also available on lists is count, which counts the number of occurrences of a value. In contrast with tuples, lists are variable length and their contents can be modified in place. You can define them using square brackets or using the list type function. Lists and tuples are semantically similar, though tuples cannot be modified and can be used interchangeably in many functions. The list function is frequently used in data processing as a way to materialize an iterator or generator expression. Elements can be appended to the end of the list with the append method. Using insert, you can insert an element at a specific location in the list. The insertion index must be between 0 and the length of the list inclusive. The inverse operation to insert is pop, which removes and returns an element at a particular index. Elements can be removed by value with remove, which locates the first such value and removes it from the last. If performance is not a concern, by using append and remove, you can use a Python list as a perfectly suitable multi-set data structure. Check if a list contains a value using the keyword. Similar to tuples, adding two lists together with plus concatenates them. If you have a list already defined, you can append multiple elements to it using the extend method. Note that list concatenation by addition is a comparatively expensive operation since a new list must be created and the objects copied over. Using extend to append elements to an existing list, especially if you are reading up a large list, is usually preferable. Thus, is faster than the concatenative alternative. You can sort a list in place without creating a new object by calling its sort function. Sort has a few options that will occasionally come in handy. One is the ability to pass a secondary sort key, that is, a function that produces a value to use to sort the objects. For example, we could sort a collection of strings by their length. Soon, we'll look at the sorted function, which can produce a sorted copy of a general sequence. The built-in bisect module implements binary search and insertion into a sorted list bisect. Bisect finds the location where an element should be inserted to keep it sorted, while bisect insert actually inserts the elements into that location. The sorted function returns a new sorted list from the elements of any sequence. The sorted function accepts the same arguments as the sort method on lists. Reverse iterates over the elements of a sequence in reverse order. Keep in mind that reverse is a generator to be discussed in some more detail later, so it does not create the reverse sequence until materialized. While the values of a dict can be any Python object, the keys generally have to be immutable objects like scalars, types, int, float, or string. For tuples, all the objects in the tuple need to be immutable too. The technical term here is hashability. You can check whether an object is hashable can be used as a key in a dict with the hash function. To use a list as a key, one option is to convert it to a tuple, which can be hashed as long as its elements also can. Now let's get on to part 2, functions. Functions are the primary and the most important method of code organization and reuse in Python. As a rule of thumb, if you anticipate needing to repeat the same or very similar code more than once, it may be worth writing a reusable function. Functions can also help make your code more readable by giving a name to a group of Python statements. Functions are declared with the def keyword and returned from with the return keyword. Functions can access variables in two different scopes, global and local. An alternative and more descriptive name describing a variable scope in Python is a namespace. Any variables that are assigned within a function by default are assigned to the local namespace. The local namespace is created when the function is called and immediately populated by the function's arguments. After the function is finished, the local namespace is destroyed. Consider the following function. When I first programmed in Python, after having programmed in Java and C++, one of my favorite features was the ability to return multiple values from a function with simple syntax. Here's an example. In data analysis and other scientific applications, you may find yourself doing this often. What's happening here is that the function is actually just returning one object, namely a tuple, which is then being unpacked into the result variables. In the preceding example, we could have done this instead. In this case, return value would be a 3 tuple with the 3 return variables. A potentially attractive alternative to returning multiple values like before might be used to return a dict instead. Currying is computer science jargon that means deriving new functions from existing ones by partial argument application. For example, suppose we had a trivial function that adds two numbers together. Using this function, we could derive a new function of one variable at 5 that adds 5 to its argument. The second argument to add numbers is said to be curry. There is nothing very fancy here, as all we have really done is define a new function that calls an existing function. The built-in functools module can simplify this process using the partial function. Another even more concise way to make a generator is by using a generator expression. This is a generator analog to list, dict, and set comprehensions. To create one, enclose what would otherwise be a list comprehension within parentheses instead of brackets. This is completely equivalent to the following more verbose generator. Generator expressions can be used instead of list comprehensions as function arguments in many cases. Let's get on to part 3, files and the operating system. Most of this book uses high-level tools like pandas, read CSV to read data files from disk into Python data structures. However, it is important to understand the basics of how to work with files in Python. Fortunately, it is very simple, which is one reason why Python is so popular for text and file munging. To open a file for reading or writing, use the built-in open function with either a relative or absolute file path. By default, the file is opened in read-only mode R. We can then treat the file handle F like a list and iterate over the lines like so. The line comes out of the file with the end of line marked as syntax, so you will often see code to get an EOL free list of lines in a file like. The default behavior for Python files, whether readable or writable, is text mode, which means that you intend to work with Python strings. This contrasts with binary mode, which you can obtain by appending B onto the file mode. Let's look at the file from the previous section. UTF-8 is a variable length Unicode encoding, so when I requested some numbers of characters from the file, Python reads enough bytes, which could be as few as 10 or as many as 40 bytes, from the file to decode that many characters. If I open the file in RB mode instead, read requests exact numbers of bytes. Depending on the text encoding, you may be able to decode the bytes to a string object yourself, but only if each of the encoded Unicode characters is fully formed. If there are any problems while following me through, welcome any questions. Thank you for listening and have a nice day. Bye.